Konnichiwa. My name is Julian from Taiwan, and I'm a backend engineer in charge of the developing of a service called Line Now. And today I will talk about how to use the Docker to set up the local developing environment for developing microservice. Here is my agenda today. Since I only have 10 minutes, so I won't go through the detail of what is Docker or what is a container. But if you have a interest of what Docker and the container can do, there is another session in 420 in Hobby that my beautiful colleague will introduce you about more detail about what we use the container, how we use the container. So here I will talk about what's a microservice and what's the problem with when we developing a microservice, and how container and the Docker can help us to solve these problems. And this is a microservice with those stack, and I think most of you might be familiar with this kind of the architecture. It's a modern architecture that help us to build up the scalable application. And in this kind of architecture, each function is separated each function into a different kind of service. For example, we may have a user service that is in charge of the user registration or user management, and we might have a payment service that is in charge of payment, and some we may have a shopping cart service for handling the shopping cart. Each service might communicate with each other through the RESTful interface. So this it will help us to build this kind of a huge service very quickly and make it scalable. But what's the problem with when we're developing microservice? As a developer, I might only in charge of some services. For example, I might be the developer of the user service, but I don't care about how the payment service does. And but there is many dependencies. For example, the user service might depend on the database or another service, and the payment service might depend on another service. So it's difficult to us to set up a developing environment that contains everything. So when we try to develop such kind of services, for example, when I'm developing the user service, I cannot. It's not easy to test all the dependency on my computer before I commit the code. So that's what we do. Like, for example, I am the developer of the service tree, and this is what I really care. But there is a dependency that the web UI depends on my service through a RESTful interface, and I also depend on another two service called service 4 and service 5. So, but I am the developer of the service tree, so I don't understand, or I don't know what will be implemented in service 4 or service 5 and web UI. But I do need to test before I commit my code. So this is the problem that we encounter in our daily life. So what we might do to solve this kind of problem? First, we might use the fake data, or we say mock data, to develop. When we have after we define the RESTful interface, we can set up some mock data or fake data to test our code before we commit the code, and then we test the code and commit the code and deploy to the real environment. But it's not precise. Not precisely the data will not precisely with the real environment. So because it's fake. So another we can do is we set up an alpha environment, so we can commit a code to the alpha environment and test it in the alpha environment using the real case. But the problem is from the deployment, from the development and to the deployment, it takes long time to deploy the cycle. Takes very long times. So, and there is a lot of service in Alpha environment. We don't have control over that. For example, I'm the developer of a service tree. I can control what version of the code I need to deploy to the service tree, but I cannot control others to deploy their services. So maybe someone, for example, service 4, the developer of service will deploy the latest code that is not compatible to my interface. So that will might cause problem. So it's not easy to test through this kind of environment. So you need to set up the full environment on your computer to test all the things. But to set up the full environment on your components is very difficult, because each component, each service has its own dependencies. So service 1 might have its own dependencies, and the service 2 have another dependencies for library or for the network, for something else. So we need a thing to help us to build the component, contain all the service, and then run it once on our own computer and test our codes. So Docker can solve this kind of problems. So with Docker, we can easily set up the development environment in minutes. How we can do that? Because we can package each service into a Docker image and deploy to the Docker registry. And if someone needs the image to run in at the local computer, he can pull the image down and run it at his local component. So, and we can have a consistent environment and testing in the local. So what is a consistent environment? A consistent environment is that we can have the same configuration, or for example, network configuration, application configuration with the real production environment. And we can use that to test the real case before we commit the code. And since each service is packed into the Docker images, we can easily to swap different components. This is the example. From the diagram, we can see that we pack in each service into a Docker container. For example, we have a service 1 as a container, and service 2 as another container, and service 3 as another container. And as a developer of a service 3, I want to run my code on my local computer. So the container is quite different from others. The container link the code from the local computer, and other container run on my computers will be selected by the version I want. For example, I depend on the service 4 and service 5. So I want the latest code on service 5 and service 5. So I can choose the different branching for that. This is how I pack my container image to deploy for the others. We have the Docker files, build script, source code, and application computer, and build it into images and deploy it to the registry. Others simply pull down the images and run on his local computers. And for the local images, I simply extract the source code. I use the Docker button to mount the source code, not build the source code into the images, so that I can change the source code anytime to verify my codes. That's what I do in my local computer, local version of the source code. And we can use the Docker Compose to run all the containers at once. For example, we have service 1 and service 2 and Redis. We can have the Docker Compose.yaml file to specify which component which container we need to run, and the dependency of each container. So we can use the Docker Compose to run them at once. So here's the tips when I using the Docker to build up the development environment. The first one is please use the smaller based images, because I think everybody like to use the Ubuntu as the best image, but the Ubuntu is very huge. So if you have many services need to use that consume your hard disk space. And try to avoid install unnecessary packages. Only install the package you want for your applications. And each container should have only one concern. The container is not virtual machine, so you don't want to run Redis and the MongoDB in a single container. You will run it on the several containers. So that makes us to focus on what we do. And you can tag the container version with the Git information, for example, Git hashtag. That will help you to quickly select the code you want to verify your code. Okay, that's my presentation today. Thank you very much. And then you have interest over what container can do, you can go to the whole bit for another session. Thank you very much.